And we are live. What is up, hackers? And welcome to a new series of streams. This is the opening chapter of a whole series of the live coding streams where I had, uh, when I was thinking of the whole streaming thing, I was having plans to eventually do two more things. Well, maybe three more things. Uh, One will be streams where I tinker with guitar. And for that, I need to set everything up, like set the Reaper. I decided to go with Reaper as the DAW of my choice. And obviously you need to like connect it with OBS and do the initial setup, right? Um, and another one is to do live coding, which is which might be actually uh, I don't know, it might be refreshing, and it it falls hardly into my domain of expertise because uh, I'm an engineer, I'm a programmer, and I've been doing that professionally for more than 10 years at this point. And so, yeah, that's kind of one of my strong things where I can maybe uh, give some insights to people. Uh, and another side of that uh, is that I rarely do the whole coding things not for work anymore. And I remember how I used to enjoy that stuff, and I mean, I got into into that thing because it was interesting for me, and I vividly remember that first, I don't know, like 5 years of my career, I was constantly tinkering with my setup, constantly doing stuff with like my configuration, and constantly doing uh, IT, let's say IT and tech stuff, not connected with my job. And nowadays, it kind of feels like I'm falling into the um, pit where I'm like, I don't want to do it. I kind of want, but I don't know. It's like lately, I haven't been doing much of tech stuff. I haven't learned any like technology or programming language in years, especially something personally not connected with my job. With my job, yeah, I got a hang of Golang a year ago, uh, but yeah, that's kind of the premise of it. And automation is the key. Like, I eventually need to set up all of that stuff. So it just makes sense to set it up properly uh, and take time in learning new stuff and polishing the solutions. Uh, I was kind of pushed a bit more into that recently when I actually let me check out whether the chat is working. Uh, Hold on a second. So yeah, uh, on the Christmas holidays, I was there was one day when I was thinking like, okay, I'm gonna start setting up some stuff. But before that, I wanted to set up my Wi-Fi router. I have two MikroTik routers, and I wanted to set up the Wi-Fi network, which would allow for roaming between the access points, something that you would see, I don't know, in some companies or like airports, I don't know, at your university or something, right? Where we have one network but a bunch of access points, and your phone or your laptop doesn't, it migrates from one access point to another, and you don't even notice that. You can still be on a call and everything. Uh, and so, yeah, I was aiming to do that. Initially, which was ironic, initially I thought that, huh, I'll set up Capsman because, like, MikroTik, they have a tool called Capsman, which is actually, I don't know the disambiguation of that. Uh, but basically, it's. Do they have like. Oh, okay. So it's Controlled Access Point System Manager. All right. So it is a management solution for access points and networks. And so I jumped into it and I spent whole 4 freaking days on it. That was something, I should say. That was something. Uh, I expected it to take a couple of hours, but it didn't work out that well. It didn't work out that well. What was cool though, like I I got to the setup I'm pretty happy with. Uh, I put so I switched to routers. Previously, I had my old, let's say, legacy router. Right, it was HAP AC2, which was above my door, and it was both acting as a switch plus access point. So, like above the door, you have the Ethernet patches that go to the Ethernet sockets in the apartment, two sockets in the apartment. And so I got a second router at some point, HAP AX2, and initially I just put it as a basically access point plus switch. So it didn't do any heavy lifting in terms of routing, in terms of logic and networking. It was still mainly um, the domain of my previous old router, and I put the newer one in my room. And for the whole Capsman thingy, it kind of requires more resources. So I came to the situation where I couldn't, like, if I would load my main old router even more, like it had like, I don't know, 128 megabytes of memory, the RAM, I mean, uh, in contrast with like half a like 500 gigs or something of an AX. So I needed to switch them in places, and that didn't went as smooth as I expected it to be. So I almost bricked uh, one of the routers, but yeah, at the end of the day, I kind of persevered, and now I have a nice setup where my main router uh, is located above the door, and not only it does all the heavy lifting. So in my network, I have a VPN connection. I have some routing between the VPN network and the internal network. So if I'm connected to my on my phone to the VPN, I basically can go to all of the devices from my home network because my VPN server connects to my router, and we have basically site to site, something akin to site VPN connection when you uh, take two networks and connect them together using VPN as a, let's say, bridge. Not literally, but yes. Actually, it is literally a bridge, but yeah. Uh, and now I was able to also utilize PoE connections. So my previous router didn't have PoE out, it only had PoE in, and PoE is power over internet, which is basically, instead of plugging like Ethernet cable to your router and then plugging a power supply into your router, if you have a device that supports power over internet, Ethernet, sorry, power over the Ethernet, power over Ethernet. Jesus Christ, words are hard. Um, so that device can take power. So you can basically power devices using the Ethernet cables. And given that my new router has PoE out, the second router now don't, like, it's a very clean setup. You only have uh, Ethernet cable going in it, and it powers up, and everything works. That's pretty cool. Also, I've set up. What's cool about this Capsman, so managed access points. I don't know how to, like, it's not mesh, because mesh kind of implies, like, nowadays you have a lot of consumer hardware which provide mesh Wi-Fi solution, and in case of mesh, you basically get several access points and they connect to each other wirelessly and they do the coverage. You also probably, like, manage them. I don't know. I'm not sure about the consumer stuff. But here with this management solution, and I'm pretty sure you will, like, you definitely have something similar in stuff like Ubiquiti. Someday when I'm not as poor, I will definitely try Ubiquiti hardware. Those guys, they're looking great, and they're using Debian uh, on their, like, routers, and probably on all their hardware. I don't know actually, but yeah, they're using like proper Linux distribution, something not like Microtic, which uses. I mean, it. I'm pretty sure it's Linux at the end of the day, but you don't have any access to it. It might actually very well be just a custom OS, although I'm not that sure. Uh, so yeah, the cool thing is that you're operating in the context of radios. Let me actually. Uh, I can try to kind of illustrate what I'm talking about. Also, I want to take a look whether we have sound on the stream. Okay, okay, we do. That's good. That's good. We have sound. Everything is working. Uh, do you have any like schematic for a capsman? Not the best illustrations, but yeah. But yeah, basically, like you kind of have your main controller and you attach devices which have radios in them. And as you know, the Wi-Fi router, like usually consumer Wi-Fi routers have two radios in them, one working on 2.4 gigahertz and the second one on 5 gigahertz. That's literally two radio modules, two sets of antennas, I think. Uh, Not sure that they can use the same antennas, uh, at least because like the wavelength is different, right? So yeah, and in this scheme, you are uh, operating on the level, like you're operating by radios, and you can create what is incredibly cool is that you can create more access points than you have radios, or less access points than you have. Well, technically it's not less, but it's so basically like what I did. I don't know if I can show it. Let me take a look. Mm. Let me take a look. Yeah, for example, like this is what I ended up with. We have, technically we have four radios because we have two routers with two radios each. And then we have several configurations. And what I am basically running here is there is one access point with two 5G, 5 gigahertz radios plus one 2.4 AX, so Wi-Fi 6 2.4, and they are combined into a main network, something that I was initially aiming for. So this single network devices roam between the access points. But what's also cool is besides that, I also got set up a separate network for the IoT devices, which run only on single radio and only 2.4 because they don't need 5 gigahertz. And another network, so another Wi-Fi network for guests. And out of them, IoT devices, they are isolated using VLANs. So they're isolated using VLANs into their separate network by themselves. Like they get absolutely different IP addresses than the IP addresses. Like it's a different network. They get different IP addresses, and they cannot access devices on my main network, which is good if you have some, I don't know, freaking dishwasher with Wi-Fi, and like smart dishwasher that will eventually get hacked. And if it gets hacked, uh, it can't do much because it says that it only has internet and it doesn't have anyone around him. Aside from that, the guests network, well, they IoT devices can access only Home Assistant server, and that's pretty much it. And guest network can't access anything. So, like, for example, if I give you my guest Wi-Fi, you won't be able to see the like go to the router page or do anything. You would just have internet, which is kind of neat. That was quite a rant. Also, I need to test the freaking chat, man. Oh, I'm looking at it and it's okay. Chat test. Let's see. Okay, chat test works. It works. It's good. All right. Damn. I need something on the second screen. Okay, let's just for now just put the terminal in here. Okay, that looks good enough. All right, let me. Okay, so we need to come up with the plan. I will. Do I have projects in here? Okay, what do I have here? Well, we have Nix packages. How long will it take to pull the Nix packages from here? Man, I'm really starting to consider the moving on to like 1 gigabit internet connection. Like now I really want that stuff, because I'm starting to feel especially with NixOS, sometimes you're starting an update and it starts downloading like 40 gigs and you're like, that's gonna take a while. Okay, so Actually, I should have started tmux here. Like, I need to create like a to-do list of what we are planning to do and what we need to do. And for that, I need my terminal. I mean, I guess I can just like open another one. So, all right, that should work. Okay, we have fish. All right. Okay. Well, that's Nix packages. That's pretty cool. All right. So, what the hell do I have in OBS here? Okay, we will get to it a bit later. All right, let's just create a file called nodesmd. Oh yeah, I'm not freaking sharing the screen. And let's try put all of my wishes in there. So first, what do we want to do first? Like, we definitely need our OBS plus Reaper. Flake and testing setup VM. OBS plus Reaper. Flake system integration. What is that? It's our to do. To do infra setup. Okay, whatever. It's gonna be just to do. Okay, so we will need OBS plus Reaper, Flake, and testing setup via virtual machine. OBS plus Reaper, Flake system integration. What we also need to do is terminal filter for sensitive data. Okay, let's do it like that. Terminal filter for sensitive data. OBS. What was the name of the plugin? Yeah, I think this guy allows me the devices to. Okay, easy setup, many customization. Okay, so OBS MIDI MG, whatever, MIDI setup for scene switching. What do we need also? Also, we will need an email server. Um, virtual machine deployment via Nix. Mail call server. I think that probably should be okay. What? Well, I guess like OBS plus Reaper, Flake, and test and setup kind of falls in. Yeah, yeah, I think it should work. So basically, um, the thing with NixOS is usually if you have configuration applied to your system and you're changing something and reapplying the configuration, you're basically rebuilding your system. After the system was rebuilt, it will restart the network services. You will technically probably like, yeah, it won't close a lot of apps, but yeah, basically it's hard to do on stream. So like if we are gonna use that on stream right away, and if I'm gonna rebuild the system, uh, it will just drop the stream. And in general, like if something breaks out of the stream and so on and so forth, so we need to figure out the way uh, how to test crucial parts of how to test the configuration for the streaming machine uh, without actually applying it. So for that, on Nix, we can utilize virtual machines. So technically, instead of building the configuration you have and applying it on your machine, you can build it and apply it to the virtual machine, which is much better way if you want to ensure whether it works or not and run tests on it and so on and so forth, and not break your freaking stream while doing so. Yeah, I think that should probably be enough tasks for today. Let's put some ambitions in there. Awake on LAN for PC. If WireGuard traffic goes to it, the next comfy UI llama, and that's gonna be kind of like that. That's gonna be kind of it for this for starters, but in general, actually not comfy UI either. So at first, let's do either or either. I don't know. So it's basically like self-hosted Copilot. Let's say I want to eventually come to the point where I would self-host all of the AI thingies and write own AI agent. Do we have Emacs here? No, we freaking don't. Oh, we have freaking Visual Studio though. Don't have Emacs, but have Visual Studio. Jesus Christ. What became of me? What became of me? Okay, so OBS, Reaper, Flake, and testing setup. Right. Oh, damn, dude. Like, I think at first we really need like caches. However, caches is right, let's put it number 2. Caches. Okay, so I guess we will need to start with OBS plus Reaper Flake. Right, all right. Okay, I'm gonna take a small pause, and I will be back in like 5 minutes, and we will actually start doing shit. So see you in a bit. All right, we're back. And so let's share the screen, clean whatever BSP box question. Oh, okay. Microtik, AP controller. No, that's not what I need. Yes, that's my shamelessly generated, shamelessly AI generated thumbnail. Okay, let's do description of what this space is and okay, let's do a quick setup of the perplexity. So prioritize, prioritize the information from official NixOS wiki, Nix bills, and directly Nix packages source code. Aim for text. Up-to-date, aim for the modern and up-to-date coverage of Nix-related questions. Okay, that should be good. All right. So let's try to clear up a bit what we want to do and kind of create a plan, the more technical plan. Okay, so I want to create Nix Flake with the OBS plus Reaper setup for streaming. This flake should be later imported into my main configuration flake, but it should preserve its own Nix packages locked. And updated. Since I'm working on the flake during the string, it should be possible to test it without rebuilding, to test it without rebuilding the whole system configuration. like in dev shell or in a virtual machine. Research best practices in creating such modules. Provide me with links and learning materials, as well as with several several options for such implementation. We are aiming for the for learning process of Nix and NixOS. We will also need to package. All right, let's start with that. Okay, let's see what our AI will tell us. In the meantime, we'll go for my NixOS. Learn NixOS. Zero to NixOS guide. I don't even know like what we NixOS guide. Okay, 7 months ago. That's with essential application. Oh no, I don't need that. Zero to Nix, your guide to learning. Yeah, that's a reputable source because Determinate Systems are the company that is run by the guy who actually created Nix. Okay, NixOS virtual machines. What is up with that? One of the most important features of NixOS is the ability to configure the entire system declaratively, including packages to be installed, services to be run, as well as our settings and options. NixOS configurations can be used and to test and use NixOS used on virtual machine independent of an installation on a bare metal computer. Okay, so far here it looks like we are just like setting up the general configuration.nix, and then what is up with that? Okay, so like we are building it. Nix packages channel, okay. Let's see. Okay. So the damn, I forgot. The Clanker produced something. Okay, best practices for modular NixOS streaming Flake. Flake parts documentation, modern framework for modular flakes, highly recommended for. Okay, Flake parts. Core of a distributed framework for writing Nix flakes provides the options that represent standard flake attributes and establishes a way of working with system. Opinionated features are provided by an ecosystem of modules that you can import. Flake parts itself has the goal to be a minimal mirror of the Nix flake schema. Used by itself, it is very lightweight. Okay. Why modules? Flakes are configuration. The module system lets you refactor configuration into modules that can be shared. It reduces proliferation of custom Nix glue code, similar to what the module system has done for NixOS configuration. Like NixOS, but following Flake spirit, Flake parts is not a monorepo with the implied goal of absorbing all of the open source, but rather a single module that other repositories can build upon, while ensuring a baseline level of compatibility. The core attributes that constitute a flake features split your flake Nix into focused units, each other take care of system. Okay. Okay, here we have official guide, which is not that useful. Missing hardware acceleration. Yeah, that's yes. Enable virtual camera. Yada yada yada. Okay, that's pretty much useless. How G photo 2. Okay. Jade, FYI. Jade. That looks familiar. Also, when I'm gonna be remembering the ambitious projects, I'm gonna be putting that shit in here. What did I want? Blog. Like chatbot which can post on my blog. Okay, chatbot. Flakes aren't real and they cannot hurt you. Okay. Dendritic design pattern? Jesus Christ, what the hell is dendritic design pattern? A guide on how structures your Nix code with flake parts using the dendritic pattern. With many other programming. Okay, what the hell is dendritic pattern? Dendritic. Jesus Christ. I adore this idea of every file is a flake parts module, and I think I will adopt it everywhere. Okay. NixOS home modules and NixDarren are popular projects that allow the user to produce derivations. Yes, that's true. Figuring out the practical and excessive architecture for code base. Yes, re-architecture. Yes, that's true. Dendritic pattern. Jesus, could have you like just settle on the simpler name? The dendritic pattern reconciles these factors using yet another. Sure. Yeah, I think it's good. Using yet another application of the Nix packages module system, a top-level configuration. Top-level configuration facilitates the declaration and evaluation of lower-level configurations, such as NixOS, Home Manager, and NixDarren. Isn't it what I'm doing now? Commonly, this top-level configuration is a flake parts config. Okay. In the dendritic pattern, every Nix file is a module of the top-level configuration. In other words, every Nix file is a Nix packages module system module that is imported directly into the evaluation of the top-level configuration. Why? Implements every Nix file also implements a single feature across all configurations that the feature applies to. Is add a path that serves to name that feature. The parent typically involves storing lower level configuration. Man, I'm kind of wondering a tiny little bit about my microphone. Sorry, I'll try to put it just a tad higher. We will see. I mean, I think it's, yeah, like levels of the mic are pretty good. So the pattern typically involves, oh yeah, that's all right. Actually, do I have filters here? Compressor. Sidechain, no. Ratio, threshold, attack. I don't know, man. How do I freaking set up a compressor in OBS? How to set up compressor in OBS for stream? Is this like enabling and disabling it? I don't know, like. So technically, compressors. Oh damn, we have some kawaii desu. Okay, what is OBS compressor? Function within it. I mean, compressor is the thing that makes loud noises less loud and quiet noises, quiet sounds more loud. It is also the thing that used to butcher a whole lot of digital music, especially on CDs, and people, the industry, loves to compress the shit out of music, unfortunately. Okay, ratio automatically adjusts the volume during the streaming when your voice gets louder, ensuring that viewers receive easily audible sound. With the default setting 10:1, okay, 10:1, even if you speak 10 times louder than usual, the perceived volume remains relatively constant. By setting the ratio, you need not worry about startling your viewers with loud voices. Loud voice. Okay, okay. Now I can definitely feel and see the difference. I think so. Yes, no, yes, no, yes, no, no. I don't. No. What the hell? What the hell? I I mean I can kind of hear the difference, but like so here it should be currently applied, right? But that I don't know, man. Ah, okay, okay. That I mean I guess it somehow works. Even if you speak 10 times louder than usual, the perceived volume remains relatively constant. By setting the ratio, you need not to worry about startling your viewer with loud voices. When you set to a 3-to-1 ratio, loud voices are slightly suppressed, resulting in a natural finish. On the other hand, 10-to-1 ensures that loud voices are controlled to a nearly constant volume. Okay. Um, so I guess we should, like, I don't know, do 5 here. 5. I'm gonna make a bunch of weird ass sounds. Don't. What the hell, bro? What is it even working? I don't know, dude. What the hell? What the hell? I don't see anything changing. Yes. I mean, I don't know. Um, I mean, we can take a look at the levels of a microphone output, but it's like currently it should peak as hell, and with engaged compression, I don't hear freaking difference, dude. Attack, massive attack, output gain. Okay, output gain works. Like it works. That means that ratio should also work. I don't know, let's just like put it as 5. It bothers me that I cannot like hear the difference very much. Threshold is a parameter for adjusting the sound level at which compressor starts operating. Minus 18 dB. Okay. Oh. Okay, standard is minus 18. So technically, if we are like setting it at minus 50, okay, now I freaking hear that. Now I so oh, it's not threshold. It's basically a target. So it's like if we are putting it at like minus 30 and we would start like making loud ass noises, it would kind of limit that shit. It would target for minus 40 dB, which is pretty cool. Okay, minus 18. I mean, minus 18 sounds not bad. What about minus 30? Minus 30, like minus 18 sounds good. Sounds good. Uh, Starts by setting it around the default and gradually adjust it while conducting test streams. I don't know in which direction should I adjust it, but okay. Attack time. Attack time is a parameter that adjusts the time the compressor takes to start operation. Reducing the attack time speeds up the response, allowing sudden loud voices or noises to be swiftly suppressed. However, if the attack too short, the sound may become unnatural or subtle sounds might be lost. Begin with the default value of 6, more like 60. Oh, yeah, it's 6. Okay. Release time. Setting to adjust the timing when audio processing ends. If the processing suddenly ends when the volume is gradually decreasing, output gain is a function that adjusts the final audio volume after compressor processing. Well, oh, actually, like, if we are doing that, we should, yes, now we like, now we hear the difference. 0 dB. I don't know, man. It's like if I'm speaking very, what if I like do something like that? It should be like, or I don't know, take the mic and try to like talk really quietly, and it's still like not very quietly. But I mean, in comparison with that, it is. So, and now if we will engage the compression, I don't know, man. I don't know. It's still like it still sounds like we have a dynamic range. Um, I don't know. Mm. Noise suppression, noise gate. No, we don't have that. Gain. How to add plug gains to audio filters. Man, are there recommended ones? Okay, recommended settings. 3 to 1 to 10 to 1. Okay, we put like 5. What if like it's 1? Like oh, okay. Okay. It seems like 1. I don't know, man. I don't feel freaking difference. It's like that's like 32 and that's 1. Okay, I can kinda maybe little bit feel the difference, but not really. I don't understand. I don't understand. I don't understand. So 1-to-1 ratio should be, that's us literally like we're gonna become a Japanese VTuber. I don't know, man. I don't hear like very much. Like I don't hear a lot of difference in here. But okay. Okay, now I know what sounds to make to test the compression. However, like, let's freaking ask AI. I don't know, man. Um, Setting up a compressor for my microphone in OBS for streaming. Okay, let's see what the clanker gave us. Ratio determines how much volume reduction applies when your signal exceeds the threshold. A 3:1 ratio means that for every 3 decibel above the threshold, only 1 decibel comes through. Does OBS compressor elevate quiet sounds? Oh, okay. So OBS compressor does not elevate quiet sounds. It only reduces loud sounds. Okay, that explains why I didn't notice any difference, because I was exactly testing it for that. I mean, okay. I guess then it's fine. 5. And then let's put it at -20. Let's put it at -45 so we can scream and shit. Okay, -20 should be good. Because, like, now it will try to aim for -20, and -20 is kind of like how I'm speaking right now. It is -20. And now if we are gonna be like very loud, it's gonna adjust. Cool. Good to know. Okay. Then I guess we'll just like go on with these settings. Okay. Now we had spaces. This one, this guy. Okay, let's continue with Nix. Okay, it suggested us 4 implementation approaches, which is not bad. Option 1, standalone streaming flake. Best for learning and iteration. Okay, separate directory, separate repository actually, independent inputs, all Nix packages bin, dev shells, modules, tests. I mean, sounds reasonable. Independent Nix packages updates. When to integrate to main. Okay, let's take a look. During development, so we do Nix develop to enter shell. Cool. So we can test it in the shell. We can rebuild VM. That's cool. When ready to integrate, what? Imports, streaming setup, NixOS modules, default. What? Flake parts. I think we need to go with flake parts. Like, so we have flake Nix, flake modules, streaming system dev shell. Okay, what are partitions? Multiple Nix packages, version in partitions without evaluation overhead. Okay. Flake Nix with flake parts. Inputs, flake parts. What is that? Professional. Okay. Overlay based module. Multi-system setup, or when you need maximum portability. Home manager. Nah, we are not going home manager. I'm still thinking of just getting rid of the home manager because I've been using it for quite a while, and for quite a while I mean like 5 years or something, and I'm not sure if I need it. It's like, do I really? Like, I have a plan of moving what can be moved out of home manager configuration. I want to move it into like system configuration level. Testing without system. Yeah, that's from the NixOS wiki. Okay. Okay. Concisely. Concisely. Explain to me what flake parts is, its main concepts, and how to work with it and organize configurations. Yeah, you know what? I also need to freaking update my channel thingies. Okay, is a framework that adds a module system to Nix Flakes. In standard flakes, you must repeat yourself for every system. Packages, okay. With flake parts, you write once in per system and it auto expands. Okay, per system is basically like different architectures. like different deployment targets, right? Oh, okay. Dev shells packages. Okay, all right. We hide the abstraction, like we hide the level of specifying build targets. Let's call them build targets. A function that runs once per system you declare. Huh? 3 core concepts. First, the per system block. A function that runs once per system you declare. Arguments include packages, system, self. Self is your flake outputs, okay. Inputs, okay. All configurations merged for this system, okay. Example, per system. Packages from other flake, okay. Didn't get that, but let's read through the module composition. Split your flake into focused files, each handling one concern. OBS Reaper VM dev shells. Okay. Each file is a module. Simple function that returns a config. Cool. Then import them in flake.nix. Automatic merging. Unlike plain flakes where duplicate attributes error, flake parts merges them automatically, just like NixOS module. Oh, that's cool actually. Okay, first modules, second modules both get merged into the final config. Okay. Elaborate a bit more on per system. Is that our deployment build targets? Oh shit, it has like shit ton of stuff in here. Module composition, automatic merging. Okay, organization pattern for string setup. Best structure for your OBS plus Reaper flake. Flake.nix. Okay, flake parts. Okay, let's use NixOS unstable, not a problem. Streaming packages, dev shells, tests. Okay. Streaming packages, all streaming tools in one place. Flake modules, dev shells. Okay. Key patterns for your use case. Per system, your system loop explained. Per system is not exactly build targets, it's more like for each system I support. Think of it as a for loop over systems. Without per system, you would write something. Yeah, but basically supported systems are the ones which can import Flake and use it. We're talking different architectures and Darwin/Linux, right? Yeah, later if you want to add Apple Silicon, that's cool, that's cool. Okay, like that sounds not bad. The whole where we had our flake parts, like I'm interested in the idea of those flake parts. Cheat sheet. Flake parts offer a couple ways to access the same thing. What I want to know, however, system Nix is the combination of operating system plus CPU architecture. Okay, device machines that can run binaries from your flake. Cool. Linux, most servers, gaming PC. Hell yeah! Most gaming PCs run on Linux according to the Perplexity. Okay, that's cool. That's cool. Damn. Darwin is like x86-64. Darwin is dying. 90% of packages work on Arch Darwin. That's on IRM Darwin. That's damn. I didn't want to believe that. I didn't believe that Apple will do that. When they started moving to IRM, I was like, holy shit. I was like, that's kind of cool, but that's incredibly hard, and they pulled it off. Holy crap. Let's start step by step. Find the configuration for OBS with the full I want to know how so in the flake parts, approach, it is not possible, recommended to import one module into another. All modules should be imported on a top level. Yeah, let's go. Cheat sheet. Get a locally defined package. Next build. Yada yada. Now best practices for module writing. Not quite. Modules can import each other, but there is a crucial constraint. It must be declared at the top of flake.nix. What? What? Don't do this, this will cause error. The module system needs to evaluate per system first to get all module arguments, but imports must be resolved before evaluation starts. This creates a chicken and egg problem. Import and top level reference inside per system. What should be the flake parts thinking of composition. Oh, holy shit, bro. What should be the flake parts? Level of abstraction. How do you compose complex configuration when one Nix flake which uses flake parts should be imported into another where is the line between module and flake? I'm asking that shit, very abstract questions. Okay. Like NixOS, writing a configuration is quite different from writing a reusable module. In configuration, you may take shortcuts which have little impact, but shortcuts in a reusable module lead to surprises in your module's users. For your module's users, do not make assumptions about inputs. The inputs are controlled by the user, so your modules should make no assumptions about which inputs are present. This way, the user is free to, for example, bundle up their inputs into a distribution, such as a company's platform module. What? By scanning through all the inputs, you can lose two kinds of problems. Do not traverse input. You trigger the fetching of all direct dependencies. Oh, okay, that's true. By recursing into inputs, you make the problem exponentially worse. Use per system. When integrating an existing library, it might be easy to add its option in the top level namespace only, as it might already expose a whole flake interface. However, as most build and test work is done per system, users expect to be able to use it in that context. Most modules are about some piece of software that it integrates. Ideally, the flake module is bundled into the same flake. This simplifies the wiring that users have to do, especially when they want to use a patched version. It's also a bit more efficient as far as fetching is concerned. Do not use overly general option names. Well, The module system allows modules and submodules to be defined using plain attribute sets or functions that return attribute sets. Okay. When a module is a function, the module system and flake parts pass various attributes to it. What? When a module is a function, the module system and flake parts pass various attributes. Okay. These attributes are called module arguments. Okay. Know that if you use the args at or arg syntax, you only receive the arguments you explicitly name in the function signature. That's fair. General module arguments. These arguments are available in all modules and submodules provided by the standard Nix module system. Config the values of the current module scope containing the merged result of all options definitions from all modules. In top level modules, config contains the entire flake configuration. Per system modules, it contains configuration that's specialized towards the given system. Okay, that makes sense. Options declares the current module scope. This is primarily useful for inspecting option metadata or creating references to options in documentation. Not clear, but okay. Option declarations of the current module scope, primarily useful for inspecting option metadata or creating okay. Lib. Nix packages library functions taken from Nix flake parts. Nix packages lib input, commonly used for utility functions. Okay, top level module arguments. All right, what I was asking the clunker. Abstraction, where to draw a line between module and flake. Crucial architectural question. Oh, nice. Writing custom flake modules. Right, we might want to kind of like read through this blog post. Flake parts is a project that on the surface is in the same field as flake utils, flake tools, and a couple of other abstractions are top. Flake modules behave similarly to NixOS modules, but they act on the flake itself. I have been bored with flake parts train for quite a while. The module I use in pretty much dev shells. Okay. Flake Nix with simple dev shell. Right, and a configurable. Okay, let's like that should summarize that right for us. Scope. One concern within a flake. Complete independently version component. Reusability within your flake primarily across multiple flake teams. Versioning. Independent version pin in flake interface. Internal, external. Oh yeah, flake part modules. One concern within a flake. Separate flake. Independently, yes, that's okay. Within your flake, primarily across multiple flakes teams. Okay, tight coupling to main flake. Interface internal, external. No, but what the fuck? Nix flake update updates everything. Nix flake updates string and setup updates only that input. Okay. Building components that logically belong in the same flake. Example, all in one project, all the string and stuff. Flake modules, yada yada, simple, coherent, fast to develop. Audio tools, Flake. Flake module inside your separate Flake. What? You'll separate Flake itself uses your separate Flake itself uses Flake parts and wants to export reusable modules. Stream setup Flake uses Flake parts internally, then exports streaming for others to import. This is the most professional pattern. Internal organization by Nix Flake, external interface by Flake output. Yeah, that's how it sounded, kinda. Okay, main system Flake imports stream and setup as input. It takes this. Okay. When ready, export as separate Flake input. What? Inputs string setup URL. Import the NixOS module. Or use packages wide. Okay. Okay, let's start step by step defining our Flake based on Flake parts for OBS and Reaper setup. Okay, now let's drag this thing here. So cool, we kind of have still like 5 hours or something. Okay. Okay, let's move it to streaming setup. Okay, Flake Nix. Layers kinda. let's type it by hand. Maybe that will help me to actually memorize stuff. Inputs. Okay, let's use unstable. Actually, I might opt in for a stable, but okay, flake parts inputs, Nix packages, sleep follows, Nix packages. Okay. So this makes this line basically makes flake parts not pinned. Outputs inputs at yeah, bridge lets you use Windows VST. Damn, that's pretty cool. Flake modules, dev shells, development shells. Okay, I'm kind of thinking like whether ask this thing to like elaborate on the syntax, because I definitely need a refreshment, or to kind of flake modules OBS NixOS unstable pinned independently. Okay, yes, that's true. We are updating it. We are controlling our flake lock ourselves. 3 modules imported. Flake parts handles the per system. obs.nix. Okay, per system packages. Packages, OBS streaming, wrap OBS plugins. Let me just quickly grab. Let me just quickly grab my actual config. Modules shared. Man, I need to refactor that crap probably also for freaking Nix flakes, flake parts. So, uh-huh. The hell? Okay. All right, I've grabbed my piece of config. Okay, let's use it like that. So, packages, wrap OBS, and here we are not using, wait, we are not using wrap OBS here. Okay, but well, packages, let's put that one in here. VLRobs, pipewire audio capture. Let's disable background remover for now. Source switcher. I didn't have it. Source record, Droid Cam OBS, GStreamer, VK capture, vertical canvas. Okay. Advanced masks. Input overlay. What the hell is input overlay, man? Oh, I know what it is. That's pretty cool. Text pthread. Okay. OBS iTunes multi-stream. I'm not using that at the end of the day, so advanced scene switcher. Well, so validate once below. Let us comment this one, and we will return to the NVIDIA CUDA support a bit later. Why wrap OBS? The plug pattern correctly includes plugins. That's cool. Flake modules, Reaper. Alright, let's just plug the whole Reaper config in here. Okay, keynotes, Reaper works natively. Flake modules, dev shells, Nix. And what do we have in our dev shells? Okay, it's not too bad. Testing without system rebuild. Okay, Flake update. Git. Wait. First, we will probably need to initialize Git repository. Let's commit it as initial commit. Oh, shoot. Okay. Cool, nice, nice. So, like, should we? So main entry point. Whoop, whoop, whoop. Imports. 1, 2, 3. What the hell, bro? Oh yeah, inputs. Ah, god damn it. Inputs. Oh, okay. And here as well. And that's it. God damn it. Yeah, we don't need this one. Okay, now we can update Flake. Cool. Let's start. I think let's start like a build of it. We will see whether it's possible or not to build it right now. Nix develop. Undefined variable self. In OBS. Flake modules, OBS. What the hell? There is no. Oh, okay. Like here it is self. Persistent packages self. Okay, I guess. Well, let's just make a clunker solve our problem. Okay, let's see. God damn it. Okay, not bad. Not bad. Oh, not OBS, we need Flick Nix. Systems per system, okay. Infinite recursion encountered, bro. Okay, outputs, flake parts, lib mk flake, systems. Then we have per system, this thingy. All right, we need to like build the configuration, and when it builds, we'll go over what's happening here, like almost line by line to understand what's happening. What? That's an infinite recursion caused by the module args packages override. The module system is trying to evaluate config, which depends on packages, which depends on config. Okay. Okay. In each module that needs unfree packages, override Nix packages locally. Okay. It's Reaper, which is not free, right? OBS is free. So Reaper system. Okay, let's just... What the hell was that? What sound? Okay, let's just try replacing all that. Okay, that shit. I think we need free only in Reaper. However, when I put Reaper in there, I get the latest changes in there. I get the following. Should I like just start a freaking Gemini or something? You need inputs with prom. Okay. Like modules. Gonna be freaking Aurora again. Damn it, dude. Attribute override is missing. Damn, it started to build. Started building. Okay, that's cool. That's cool. Then I will take a short pause, and in the meantime we will see whether the config will be built, and if it will, I mean, honestly, we should do that regardless of that, but yeah, we will need to go over the whole configuration and like understand it on the level of Nix system and Nix language. It's gonna be the most challenging part of it. But yeah, right. I'll see you in like 5-6 minutes. All right. So we had another error, and the error was because wine had a build issue. Just use Reaper without Windows VST support. Yeah, that makes sense. Let's do that. So audio tools and just remove bridge. Attribute. Okay, we need to remove it from the dev shells. Bridge. Why we need to? Oh, okay. It's a module. Okay. Okay. Let's try starting out Reaper. And let's starting out the OBS. Please shut down. Okay, unless yes, I meant to do that. Run in normal mode. Okay, it share your screen. Okay, share my screen. Okay, OBS seems to be running. Video capture doesn't work, but that's okay. Okay, so we are able to build what we have. Now let's learn what we built. Now I want you to go over the configuration and explain it in the utmost details, including the Nix language, syntax, and mechanics. Let's start from our main flake.nix. Go over the inputs and outputs of the flake. What makes flake a flake? What are the inputs? How those are supposed to be defined. After that, we'll continue with outputs. Yeah, I definitely need to like work on my headers on channels. Perfect. Now I'll provide a clean. Okay, Nix syntax foundation, attribute sets. Before analyzing your flag, understand attribute sets. Yeah, you know what? I guess I'm gonna start like kind of jotting down that stuff. Just need to select the suitable writing utensil. This one looks good. That's a lamy pen. They're not bad. Nix. Where should we like type that stuff? Probably we should type that stuff. Or whatever. Attribute set. Fundamental data structure in Nix. Dictionary slash map with key value pairs. Okay. Rules. Oh, okay. Rules. Keys are identifiers, no quotes. Values separated by equality sign. Jeez, what's equal? What's the name? Equal sign. Every line ends with semicolon, including last one. Curly braces wrap everything. Access and values. Let's Nix REPL, yes. So let x equals foo equals 1, bar equals 2. Bus equals k. Okay, just kek. Okay. In x.foo buzz. Let's try to kind of understand this part. Will that? Yeah, that evaluated. That's cool. Let x in x foo. What makes something a flake? Flake is a Nix project with the structure flake.nix, flake.log, and other files. Okay, but the output function is pure. Huh? And you're jumping all around the place. Given the same locked inputs, it always produces identical results. This is reproducibility, yes. Input section. Inputs are attribute set declare. The inputs attribute set declares what external resources you depend on. Okay. Identifier. Okay, you will use this name in outputs. .url. Okay. Flake parts inputs next. Inputs declare dependencies. Okay. URL formats. URL like this, URL like this, URL like local path. Okay. Inputs like okay, relative path, git repository. Okay, non-flake input. What? Oh, okay, like a module or something. The follows attribute. This means when flake parts requests its Nix packages, I'll use our Nix packages instead. Why without it? Flake parts has its own Nix packages. Our stream Nix evaluates two different Nix packages versions, which is slow and inconsistent. Everything uses the same Nix packages, faster evaluation, consistent package versioning. I've said to explain everything up to output. Okay, let's freaking read through that sheet. Why not? Okay, your flake Nix output section. Outputs. The outputs function. Outputs is a function that takes logged inputs as an argument, returns an attribute set of produced values. Outputs, inputs, function parameters, return value, attribute set. Okay. Uses deconstruct. What the hell? Oh, okay, that's fair. This means the same thing. Simple parameter inputs flake part, sleep, mk flake, destructuring, outputs, flake parts, yada yada. Fucking hell, what the hell is happening here? Extract and keep the whole set. What the hell? I'll save and we will continue with outputs. Don't be too initiative. Okay, I had a couple of questions here. So first one was here we've had an example. Explain this as a Nix language construct of first, let's go over a few questions. Here we've had an example. To explain what is happening here. Inputs, flake parts, inputs is a bit confusing. How are we setting this parameter? What is happening under the hood? With structuring, we touched upon the function definitions. So explain to me with spend a bit of exercise. Okay, so let's look into a few things. I'm interested in writing of this thingy, I mean, well, obviously we are here just like let something yada yada. That's an assignment. We are assigning the value. In this case, it's an attribute set to a variable. Not sure that's an actual variable. That's probably constant since it's pure functional, but I'm not sure there's like in what the hell is in here. Question first. Okay, yes, assignment. Body uses X. What the hell? Flow. Let's start defining variables. X equals something, creates variables. Variable X holding an attribute set. Ends with now use those variables in an expression. X full access attribute. Okay. The key, everything after in can use variables defined in let. Variables don't exist outside the let in block. Let yada yada config host server running at question 2 inputs flag parts inputs next packages. Let's actually PSS NixOS stream and setup, and let's create a new one, which will let's put this in here. PSS, this and this. Oh, you know what we can actually do? We can freaking do this. Ha! Nice. That might prove useful actually. So in Nix language, there is a let in. How is the construct this statement called? And I write that it's what's the name of it? Not like self-sufficient, but it's indivisible. Do we have it this word? Indivisible. Okay, we have indivisible. Hold on. Those if we do let, we are we always need to follow it with in. Does that yes, I'm absolutely correct. Nice to hear that. So let in is called the let expression or let binding. Let and in are paired keywords that form a single syntactic construct. Syntax structure let in body expression. Body section, an expression that can use all the bindings declared above. Bindings are only accessible within the in body, not outside. Order independent. Bindings can refer to each other regardless of declaration order. Flexible body. Unlike recursive attributes, any expression can follow in, not just attribute sets. Okay. Bindings are only evaluated if referenced by the body expression. Let a equals, okay, let a equals 3, b equals a plus 1 in a plus b. So if we want, so the result of every Nix file is an attribute set, right? Excuse me. Not quite right. Nix files doesn't always evaluate to attribute sets. Nix file can evaluate to any Nix value type, not just attribute sets. Cool, but can it evaluate to nothing? Is an empty Nix file a valid file? So 1 plus 2, what? Like, what the hell? So you wanna say that so we can do this, same box test.nix nix instantiate a role test nix. Damn, that worked. Well, it worked like this. Okay, it works like this. Will it work like this? Ha. No, an empty Nix file is not a valid Nix file. That's cool. Nice. As one source explicitly states, running Nix. Yes, that's every Nix file must contain a valid Nix expression. Any file must return something. And if it's a null reference. Okay. Cool, we got this part, I guess. Okay. All right, we kind of get the, I'm starting to get at least like let in. All right, let's try to do this, for example. Bus equals a bonanza what? Let x bus equal okay. Okay, now we can expose full bar. Okay, we can nest that shit. All right. A more realistic example. Question 2. Yes, you can define nested attributes this way. The dots create nested automatically. Yeah, that's true. What follows means when Flake Parts asks for Nix packages lib under the hood, what happens? Nix looks at inputs. Okay, creates if missing, looks at Flake Parts, creates if missing as, okay, looks at inputs inside flake parts, creates if missing. Looks at Nix packages leap, creates if missing. A result is a deeply nested but created with a single wait, you can add to follow up. How is add to follow up? Oh, you can ask follow up. Not bad, not bad. I will prefer to do that in a separate chat, however. Let me so in flake parts and flakes in general, we have stuff like that in inputs. Explain what it does under the hood and is it basically passing an input to external flake parts flake or setting some option? Can I pass okay, the follows mechanism. You're understanding it partially correct. What follows does. The follows attribute redirects a transitive dependency to use as an input that's already declared in your root flake. What the hell? Follows. How it works under the hood. Without follows, when flake parts declares its own Nix packages lib, Nix fetches and evaluates that specific version independently. With follows, Nix manual notes that it's generally not recommended to use follows because it breaks cache guarantees, can introduce incompatibilities, and yada yada yada. We need to take a look at flake parts. GitHub. And now we are opening this. Okay. So it has a single input, Nix packages lib URL. I don't understand mechanics in the flake parts, flake Nix. has only one input. How we are putting follows in it. Okay, only declares one direct input. Nix package's lib itself might have inputs. It is a flake too. So the structure is your flake, flake parts, direct input, Nix package's lib, flake parts, input, Nix package. Okay. But wait, Nix package's lib doesn't actually have inputs. In the specific case of Nix package's libs, it's a minimal flake that typically doesn't have any relay. It overrides the input source. It reduces duplication. So follows is an input to our imported flake, right? And follows and Nix package's lib is an attribute set, right? How follows gets inside is this unique thing, or can we shove any arbitrary shit into the flake inputs or the flake inputs? Follows is not an input to the imported flake. It's a special attribute that modifies how the flake log file is resolved. We are creating an attribute set here, but the crucial part is not passed to flake parts as input. Instead, follows is an Nix-flake resolver directive. Nix-flake system reads this follows attribute and uses it to look at flake parts, override it in the log file to point to your root's flakes Nix packages input. Functions. Oh wait, that's like Nix language, right? Why flakes are controversial. And other special directives we have inputs. Okay, so it's not much. So we can only use URL follows and flake. Additional generic type data rev not flake input. Okay. Okay. All right. We kind of got this part. Nix functions. Full explanation with exercise. Yes, please. Absolute basics. Function form. Argument colon body. Simplest function. F equals x. Like x plus 1. Huh? F equals. Okay, so here we are like we need to assign a function to something, but here F is not like doesn't have any functional stuff, but like A, B, A plus B in F5. Like that won't work, right? A, B, A plus B. Oh. Okay, colon separates arguments from body. Since Nix functions take exactly one argument, multiple arguments nest. Yeah, that's actually a very fun thing that functions accept only one argument. When I learned about it, I was like, you can freaking do everything. Like, what the hell? What I did wrong? A, B, A plus B. Oh shit. I basically just forgot to... Yeah, I forgot to do F. F5, 5, 4. Nice. So like in this case, it's basically like first function, which takes the result of partially applied function, returns this function, takes first argument, return. Okay. Partial application. Oh yeah, that's actually like, for example, right? If we have this, and then can we do let in 6? Okay, destructuring. Okay, this gives us the partially applied function. Since Nix function, yes, that's how do I write Nix functions? Should they always be assigned to some var or something? In REPL, I want to be able to define a function which will result. Well, let's just like so, which will result in a partially applied function, which I want to assign to a variable and use down the line. All functions are anonymous lambda expressions. To give them a name, you must assign them to a variable using let bindings. Okay. Both are valid, but the second one is how you create a reusable name. Okay. This creates a carried function with 2 parameters. Yes, that's yes. What the hell? What the fuck? I'm kind of starting to get it. So like let, and in the segment when we are doing let part, we can technically like do the reassignments. Equals F5 in G5. To use the partially applied, you assign it to another variable or in a file. Okay. Can we nest let bindings to oh, that's actually G, like let G equals F5 in G3. Let F equals, no, let G equals F5, F equals A, B, A plus B, in G3. Damn it. Okay, that works. Define no, Nix doesn't require any special for functions. They're just expressions. Must be assigned. To use a function, assign it to a variable. What is an expression in Nix terms? So we cannot, I don't think we can nest let bindings. Whoa, you can, okay. Can be nested as deeply as you want. You can also write it more compactly. Huh, okay. You cannot assign to the same variable twice. Or let A2 in A, well, that makes, yeah, shadowing in let A, what? Let A equals 1 in let A equals 2 in A. Okay. Should we always have something in? should always be a single expression. Yes, the in is mandatory and must be followed by exactly one expression. Okay, that makes a lot of sense. It can be primitive value, an operation, a list, an attribute set, another let binding, and a function call. This is a key concept. Everything is an expression. There are no statements. This is common in functional languages. An expression is a piece of code that evaluates to a value. Okay. Expression is a piece of code which evaluates to a value. Good. Every valid Nix code must be an expression. There are no statements like x equals 1. So when dealing with the whole pure functional programming, I should be thinking in terms of always have one thing expression which returns every piece of code is a black box that takes inputs and produces exactly one output. No side effects, no hidden state, doing things, just input. And not only every piece of code, but the code as a whole, like a program. So, comparison of imperative versus functional. Imperative thinking, x equals 5, y equals x plus 1, print y. Instead of thinking do this, then do that, then do this, think what value does this whole thing evaluate to? Let x equals 5, y equals x plus 1 in y. which gets string and wraps into a huge string of nested functions. Okay, a whole Nix program is one giant expression that evaluates to one final value. Okay, that kind of helps. Nice, not bad, not bad. Without destructuring. Okay, let's with destructuring. Instead of repeatedly accessing attributes, get person. What the hell? Name. A. Okay, person 2. Wait, what? What? So it should have attribute set passed to it, right? Gosh darn it. What? Oh shit. What the hell? Get person equals person, like that's a function, right? Like it's a function that takes attribute set as an argument and evaluates to another attribute set. What the hell? Equal person name equals person name. Let get person equals per in get person name equals Bob. Okay. Now it worked all right. Okay. Without destructuring, if we're getting an attribute set in here, we need to reference the whole shit over and over again. And if we are, what? Is there any convenient Nix REPL? Just to play around. With destructuring, get person equals. So we are. This will show us that this is an attribute set. But we will take only name from there. Okay, now I kind of get it. So in this case, we are just, well, yeah, we are destructuring. Destructuring with defaults. Ooh, damn, dude. That, like, now we're going to some freaking advanced shit, yo. World. Cool. But if we will do this, okay. All right, nice. I'll need to remember that. Function destruct. F colon. Yeah. Map. And I don't know, like h equals map years versus f equals name Neon, then years 22. Oh, that's not 221, whatever. And that is an argument to our function. And our function is returning an attribute set where we have name equals name, age equals years. And if we are calling that stuff with like name equals kick, it will produce name kick age to 1. Okay. Dot dot dot. Wait, was I doing that in the destruction or not? I think I... Okay, so... Oh, wait. But if we are destructuring here... expect all arguments defined. So f shit. I liked like writing f so much that I didn't even think that I don't need to. Whatever. So name can we like do that? Name And can we just like return null? And then do like whatever. And then do like whatever. What the hell? I don't understand. Expect a set, but found an integer. Nice. So name. Can we return an empty set? Like, we should be able to return an empty set, right? Okay. So if we are doing this name, this, and here we will put name, one page, wait, why did it freaking work? What the hell? Yeah, called with unexpected target. Okay. Why? Why we can't do something like that? And what the hell does that evaluate to? Whatever. Let f equals error expected arg h let f equals name default and okay. What I wanted to, oh, it actually explains the whole thing here, but yeah, whatever. Destruction with defaults, capture all plus bind to name. Oh shit. Okay, let's go over capture all and bind to this. What the hell? Oh. So like if you have some expressions one after another, they will just all be evaluated. Okay, let's return to it a bit later. Capture all plus bind to name. F equals args, bind entire input to args. Okay, so F equals args at AB this A plus B plus args C A shit. How? Oh, okay. Like we are binding the tail of. Okay, okay, okay. We are binding the tail of arguments that we are kind of like don't need. So F equals args at A B pum 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 A plus B plus args C. So this shit goes to args. I will just draw an arrow. So F I equals 1, B equals 2, C equals 3. That's kind of cool. I'm starting to fucking like that shit, man. Your flake example explained. Outputs, inputs. And bind entire set to input. This means takes an attribute set as an input. Extract flake parts for quick access. Keep the whole set available as inputs. Ignore everything else with this. It's not ignore, but yeah, it does. It is actually. But like, yeah. Exercise. Try these. Well, gonna be 25, baby. Destructuring. B A minus B. Okay, it's gonna be 7. That's easy. H. The result is just a number here, right? Curry. A, B, A plus B. Yeah, I mean, I already freaking, add. Oh, that's cool. Add 2, A. Well, I guess that's 7. Oh, shit, man. Okay, we have add. Now add 2 plus 3. That's cool. And now add 2 equals add 2. Add 2, 5. Well, obviously. Capture all. Okay, we did that. I kind of understand that whole thing. Process name Alice, age 30, result this. What? Oh, process equals. Okay, we have args here. Name age, process. What the hell? Where the heck did you get the result? Okay, result display equals Alice, info ID. Okay, that one is not, I mean, it is pretty simple. Then info, like basically our args will get into info. So everything except for name and age. So it's gonna be like this. Okay. In REPL, if I do Yes. Loading your flake. Oh wait, you can like show available commands, evaluate expression, okay. Bind expression to a variable, add attributes from set to scope. Not bad, not bad. All right. Because of operator precedence and lazy evaluation, your input is being parsed as a function value whose body includes the second. And that body is not evaluated until the function is called. In Nix colon, is that fucking colon? Yes, it is. Has a very low precedence, so the function body extends as far right as possible. So this is parsed like follows. Okay. The inner would be an error if evaluated. You can call it like a function, but it doesn't evaluate function bodies until the function is applied, hence no error yet. Add the parentheses around the function so the application is unambiguous. Wait, what? So the function, but what the hell? And why? Huh? What you typed? This, and this. In Nix, the function definition has very low precedence, so the function body extends as far right as possible. So this is parsed as okay. You can call okay. Okay, so everything goes to the to our, what was the name of it again? Capture. 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 So Nix language basics. Attribute set, recursive attribute set. Okay, we will maybe this allows access to attributes from within the set. Okay. Uh-huh. So it's better not to do it, but okay. Let expression or let binding. Cool. Attribute access. Okay, that's Oh, with expression allows access to attributes without repeatedly referencing their attribute set. Okay, so basically, like if we have oh shit. Set equals okay, with set man. So with is an expression, right? So with set, can we now like define a function? Huh? Damn. With set. So attributes made available through with are only in scope of the expression following the semicolon. Counterexample. With a CX. Okay. So with set, and now we can technically define a function. So f a plus b Damn, that worked. Man, that worked. Oh, Jesus, sorry. Okay, so what the hell is happening here? Nothing will change if we will do this. Okay. Can we like do 1 and 2? Okay, we cannot. This is good. But we can do this. Nice. So with set, we are passing here our set A and B. Hmm. How the heck did we do that back then? Oh, yeah. Now it makes sense. Huh? Oh, man. Okay, okay. It doesn't actually make... Yeah, that's fair. And if we do this, it works. So yeah, that makes sense. Inherit is a shorthand for assigning the value of a name from an existing scope to the same name in a nested scope. The value of a name to the same name in a nested scope. It is for convenience to avoid repeating the same name multiple times. Oh, didn't understand. Oh, okay. It is also possible to inherit names from a specific attribute set with parentheses. Jesus, what? What the hell is this? A equals X equals 1, Y equals 2, and this inherit X1. Boom. AX1. Whatever. I don't want to think about this one. Inherit also works inside let expression. Let inherit, Jesus fucking Christ. Let inherit out of fucking hell. Inherit from here basically from here we are inheriting x and y. Y in x. Bro, I don't understand this one. Oh, okay. While the example is contrived, in more complex code, you will regularly see nested let expressions that reuse names from the other scope. Here we use the attribute set x and y to have something non-trivial to inherit from. The let expression inherits x and y from that attribute set using parentheses, which is equivalent to writing let x ting 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 y pam pam pam. The new inner scope now contains x and y, which are used in the list xy. Jesus Christ. Inherit. So from these, inherit x and y in xy. Okay, kind of get that. I need to write down the width and what did we do before inherit? Yeah, it was just width. So width expression. From set without referencing a name. So so let's do another small example just so I remember. So let set equals A22 B33 C44 in with set BC. Let set equals, what the hell? Okay. Oh, shoot. With set, yeah, damn. I need to figure out the semicolons, man. So set equals in with set, and then it'll still work with set C, right? Yep. Okay, and now inherit. Inherit. Shorthand for assigning the value of a name from existing scope to the same name in nested scope. Okay, so let it is also possible to inherit name from a specific attribute set with parentheses. To indicate a specific set. Set to inherit from. Oh, so it's not from this, wait. Let A equals 1. Okay. Inherit also works in let expressions. Let inherit bloop, bloop, string interpolation. Previously known as anti-quotation. The value of an X expression can be inserted into a character string with the $sign. Okay. Also, okay, so we only are allowed to use double quoted strings. I mean, that's not bad. Only character strings or values that can be represented as a character string are allowed. Counterexample, x equals 1 in x plus x equals x plus x. I mean, let name. Only character strings. So, like, that should won't work even like that. Okay, what else? Interpolated expressions can be arbitrarily nested. in counter strings that use the $sign before the assignment name but no braces there, and no interpolated strings, but usually denote variables in a shell script. Yeah, that's fair. Indented strings. Ooh, multi-line string, nice. Double single quotes. Hello. Okay. I mean, man, writing by hand is so goddamn satisfying. I'm like, dude, need to do that more often. I like to write, man. Okay, file system paths. Paths are relative when they contain at least one slash, but do not start with one. Is it like just not bad? Not bad. So where were paths? Oh, so one dot, two dots, parent, good. Yeah, I think Since relative post must contain a slash, but must not start with one. And the dot denotes no change. Okay, that's no problem. To avoid okay, lookup paths. Okay. Functions are everywhere in Nix language. Okay, we got to this point. So we do the function definition in here. Man, why it's so freaking noisy? What the hell? That's weird. It's freaking weird, bro. Give me a second. See? What the hell? So white balance auto. We're not locking it in, although we might want to do that like eventually. Shit's weird. Shit's weird, man. Whatever. I'll figure it out later. The thing is, like, I think it was pretty much okay before. Like, I would have noticed. Like, it's crazy distorted now. But well, whatever, I guess. I don't know why it's so shitty. Some kind of potato quality. What the hell? All right. I'm gonna be back in a few minutes and also fix the potato quality. So. Yeah, I think I figured out it. It's most likely being just the zoom on a camera that I somehow accidentally engaged, and it was messing everything up. Okay. So functions. Let in. Okay, then it calls. All right. Since function and arguments are separated by white space, sometimes parentheses are required to achieve the desired result. Fair. Detailed explanation. Yeah, we all got that. Multiple arguments, we got that. Attribute set argument, we got that. Default values, we got that. Additional attributes, we got that. Named attribute set. Covered. Function libraries. In addition to the built-in operators. Oh, what the hell? We have built-in operators. What? Oh, wait. Okay. I'm a bit dissatisfied with the fact that they used that you need to multiply like 5 by 5 instead of by 5 as you would do in some like Lisp. Okay. There are two widely used libraries that together can be considered the standard for Nix language. Built-ins. Built-ins to string. So we can do something like this. In nice. Most built-in functions are only accessible through built-ins. A notable exception is import, which is also available on the top level. Import takes a path to a Nix file, reads it to evaluate the contained Nix expression, and returns the results in value. If points to a directory, default Nix in that directory will be used instead. Nice. So this way we can only input to some other like value. Okay. Packages lib. The Nix packages repository contains an attribute set called lib, which provides a large number of useful functions. They're implemented in the Nix language as opposed to built-ins, which is a part of the language itself, and probably implemented in C++ or some shit. These functions are usually accessed through packages lib. Okay. What the hell? import Nix packages. Packages lib strings to up. What the hell? This is a more complex example, but by now you should be familiar with all its components. The name packages is declared to be expression imported from some file. Okay. So what the hell did I just do? Well, good thing we have 64 gigs of memory, so okay, so that's how our packages are looking. So Nix packages is like just a huge attribute set. Not bad. That file's path is determined by the value of the lookup path Nix packages, which in turn is determined by Nix path environment variable. Okay, as this expression happens to be a function, it requires an argument to evaluate. Okay, and in this case, simply passing an empty attribute set is sufficient. Oh, because it's like an input or something. Now that packages is in scope of let in, attributes can be accessed from the Nix packages manual. One can determine that there exists a function. Man, stop. Well, guess we're evaluating Nix packages. For brevity, this example uses a lookup path to obtain some version of Nix packages. The function to upper is trivial enough that we can expect it not to produce different results to different versions of Nix packages, yet more sophisticated software is likely to suffer from such problems. Okay, let Nix packages, fetch tarball, packages, import Nix packages. Okay. Always pin your sources, that's true. What you'll also often see is that packages is passed as an argument to a function. By convention, one can assume that it refers to the Nix packages attribute set, which is a lib attribute. What? By convention, one can assume that it refers to the Nix packages attribute set. Oh, okay, which has a lib attribute, okay. Packages lib strings lambda. Well, it's actually not too slow in evaluating the whole Nix packages. Yeah, look, it's almost done. Huh. So, and okay. To make this function produce a result, you can write it to a file and pass it an argument through NixOS instantiate. What the hell? Oh, by convention, one can packages is passed as an argument to a function. By convention, one can assume that it refers to Nix packages. To make this function produce a result, you can write it to a file and pass it as an argument through Nix instantiate. Nix instantiate eval file Nix arg packages. What the hell? Oh, okay. Okay. Nix. Wait, what? Okay, so like we are doing file.nix. Here we are putting that, and like we have basically a function in the whole file. So the whole file is an expression, which is a function which expects Nix packages as an input. Nix instantiate eval file file Nix. It will give us lambda because it's partially applied, and we can add arg packages or Nix packages. Oh, okay. Okay, good. Example. Oftentimes you'll see in NixOS configurations and also within Nix packages that lib is passed directly. In this case, one can assume that lib is equivalent to packages lib, where only packages is available. Lib, let to be equals true in lib trivial or okay. Sometimes both are passed as arguments. In this case, packages lib and lib to be equivalent. This is done to improve readability and avoid repeated use of packages lib. For historical reasons, some of the functions in package lib are equivalent to built-ins on the same name. Okay, impurities. So far we have only covered what we call pure expressions, declaring data and transforming it with functions. In practice, describing derivation, the Nix language defining feature, which enables functional programming with the file system, requires observing the outside world. We'll discuss derivations later in tutorial. There is only one impurity in Nix language that is relevant here: reading files from the file system as build inputs. Build inputs are files that derivations refer to in order to describe how to derive new files. When I run a derivation, will only have access to explicitly declared build inputs. The only way to specify build inputs is in the Nix language is explicitly with file system paths, dedicated functions. Nix in the Nix language refers to files by their content hash. If file contents are not known in advance, it's unavoidable to read files during expression evaluation. Nix supports other types of impure expressions such as lookup paths or the constant built-in current system. We do not cover those here in more details as they do not matter for how the Nix language works in principle and because they are discouraged for the very reason of breaking reproducibility. Paths. Whenever a file system path is used in string interpolation, the contents of that file are copied to a special location in the file system Nix store as a side effect. The evaluated string then contains the Nix store path assigned to that file. Okay. The preceding shell command writes the characters 1 to 3. Oh, okay. Okay. Okay, and now oh no. Nix not bad, not bad. And now if we will like do something like that, it will give us 1 to 3. Okay, not bad, not bad. Such interpolation expressions must evaluate as something that can be represented as a character string. A file system path is such a value, and its character string representation is the corresponding Nix store path. Okay. For directories, the same thing happens. The entire directory, including nested files and directories, is copied to the Nix store. An evaluated string becomes the Nix store path directory. Nice. Features. Files to be used as built inputs do not have to come from the file system. The Nix language provides built-in impure functions to fetch files over the network during the evaluation. Fetch URL, fetch tarball, fetch git, fetch closure. Hell is fetch closure? Store path closure from a binary cache. Hell is closure of a store path is a set of store paths that are directly or indirectly reachable from the store path. That is the closure of the path under the reference relation for a package for the closest closure of its derivation is equivalent to the built-down dependencies. Okay, yeah, I kind of get that. All right. These functions evaluate to file system path in an Nix store. Okay. Some of them add extra convenience, such as automatically unpacking archives. Nice. Derivations. Yeah, I think we'll finish reading the whole thing. Something that I freaking should have done 5 years ago. Okay, derivations are the core of both Nix and Nix language. The Nix language is used to describe derivations. Nix runs derivation to produce build inputs, build results. Build results can in turn be used as inputs for other derivations. Okay. Nix language primitive to declare a derivation is the built-in and pure function derivation. It is usually wrapped by the Nix package's build mechanism, MK derivation, which hides much of the complexity involved in non-trivial build process. Okay. Whenever you encounter MK derivation, it denotes something that Nix will eventually build. The evaluation result of a derivation, MK derivation, is an attribute set with a certain structure and a special property. It can be used in string interpolation, and in that case evaluates the Nix store path of a build result. Example, okay, not bad. Your outputs might differ, yeah, of course. This is why we recommend to avoid lookup paths to ensure predictable outcomes, except in examples intended. What up? Lookup paths. You'll often encounter Nix language code samples that refer to Nix packages. It's syntax. This means the value of a lookup path depends on external system state. When using lookup paths, the same Nix expression can produce different results. In most cases, Nix path is set to latest channel. Okay. So it's a well-known problem that cannot be resolved without breaking existing setups. Okay. Well-known problem that cannot be resolved without breaking existing setups. Explicitly said, config and overlay when importing Nix packages. This is what we do in our tutorials to ensure that our examples will behave exactly as expected. Damn. Okay, map. What if, okay, like else impure. Okay. Updating nested attribute sets. Oh, that's nice. I kind of don't understand why they put it after the derivations, but okay. The attribute set update operator merges two attribute sets. Nice. However, names on the right take precedence. Okay. Here key B was completely removed because the whole A value was replaced. Use packages lib recursive update. Okay. Reproducible source paths. In the Nix file containing this expression in home, my user, my project, then the store path of src will be Nix store hash my project. What? The problem is what? The problem is that now your build is no longer reproducible, as it depends on the parent directory name. That cannot be declared in the source code and results in an impurity. If someone builds the project in a directory with a different name, they will get a different store path for src and everything that depends on it. These can be the cause of needless rebuilds. Nice. Use built-in paths with the name attribute set to something fixed. This will derive the symbolic name of the store path from the name instead of the working directory. Built-in path. Okay, nice. So that's freaking it. Wait, that wasn't like the official one, right? Nix language. Okay, derivations. Worked examples. The example imports the Nix expression from a lookup path and applies the resulting function to an empty attribute set. The output is assigned to the name packages, converting the attribute packages.nix to a string with interpolation is allowed. As packages nix is a derivation that is ultimately packages.nix boils down to a call to derivation. Okay. The resultant string file system path where the build result will end up. Damn, so we're like calculating ahead. That's pretty cool. I mean, well, yeah. Duh. String interpolation on derivations is used to refer to their build results as file system paths when declaring new derivation. Worked examples. So far we have seen artificial examples illustrating the various constructs. You should now be able to read Nix language code for simple packages and configuration and come up with similar explanations. The goal of the following exercises is not to understand what code means or how it works, but how it's structured in terms of function attribute sets and Nix language data types. So shell environment. Nice. So we are using packages as an optional. Okay. Let message in packages mk shell no cc packages shell. So okay. This example declares a shell environment which runs the shell hook on initialization. Nice. Explanation. This expression is a function that takes an attribute set as its argument. Yeah, I mean, like it takes, if it doesn't, it gets Nix packages. The attribute mkshell no cc of the packages set is a function that is passed an attribute set. What? The attribute mk shell no cc of the packages set is a function that is passed an attribute set as argument. This return value is also the result of the other function. NixOS configuration. Okay, so that's a function. Imports. Oh, that's actually. Oh, shit. Yeah, that's a function that returns an attribute set, so that makes sense. It's a function that takes an attribute set as an argument. It returns an attribute set. The argument must at least have attributes, config, and packages. The returned attribute set contains the attributes import and environment. Imports is a list with one element, a path to a next file, yada yada package. Fetch curl, mk derivation, recursive attribute set, src, fetch curl, yada yada yada. Okay, that made possible by the recursive set. Meta with lib from here, license, nice. Next steps, get things done. Learn more. Often it's not possible to determine from the code at hand the data type of a named value or function argument, the data type a called function accepts for its argument, which example, how do we know that x will be a function that given an argument returns a function? That given x is a function, y will be an appropriate argument. Given xy is a function, za will be an appropriate argument. And how does the caller of this function know that it requires an attribute set with attributes x, y, z? Answering such questions requires knowing the context in which a given expression is supposed to be used. The Nix ecosystem and code style is driven by conventions. Most names you will encounter in Nix languages come from Nix packages. Okay, we done here. That wasn't as scary as I thought it will be. Okay. So now let's once again take a look at our flake with the fresh as and also so the structure flake input explained exercises, that's cool, that's cool. So function definitions Nix, or the function definition is the function itself. Very abstract questions. Definition is the function itself. Okay. There is no separate definition statement. Nix functions are anonymous values, just like number 1 or the string hello. The expression evaluates into a function. It doesn't have a name. The value just floating in space. If you want to reuse it, you assign that value to a variable just like you would assign a number. Okay. Why your Apple example confused? Yeah, whatever. Oh, you created a function whose body contains an error. Wait, what? But because you didn't apply, the body never ran. Okay. All right, so let's go over that. So we have our flag definition. We have inputs, outputs, next flag anatomy. Flag definition. For the purposes of this post, let's treat a flag as a function that takes inputs and produces outputs. Okay. Flag attributes. Every heading in this section. Description. Some description. Data. Okay. Next flag metadata. Is it just a string or can I use Nix language to calculate it? What? Description is typically a short blurb. Blurb? What? Are you a bromide? Yes, this is a blurb. As a short promotional piece accompanying a piece of creative work. Not bad. The word blurb was coined in 1906. Yes, this is a blurb. All the other publishers commit them. Why shouldn't we? Misspelling the blurb in the act of blurbing. Not bad. Are you a bromide? Say in this book on 90 HP6 cylinder seller. if we do say it shouldn't, we consider that this man Burgess has got Henry James locked into the copy. Whatever. Okay, short blurb about what's the point of the flake. Contrary to the main dog, for the sample flake above the output is like this. Let's take a look once again. Path, revision, last modified, fingerprint, inputs, and this is the hash of the flake I would of a bill result, I think. Contrary to the main doc, it does not have to be one line either, but it looks weird in metadata output. A logical question is it just a string or can I use Nix language to calculate it? Spoiler, no. Description, some description results in expected string but got a thunk. Strictly speaking, description is not needed. They're present in the output Nix flake metadata, of course, or could be used by downstream things like flake register. Only outputs attribute is required. Okay. Flakes could be viewed as functions. Functions can accept some inputs to produce something that would depend on the inputs. Flake inputs are references, which are pointing to other flakes or file paths. For example, a syntax of inputs. Note that part is part of NixOS 24.05. The behavior of Nix packages input has been changed. Now it will point to the version of Nix packages used to build the system, which will look like this in the metadata. This might break running the flake as is on a system with different copy of Nix packages. On the other hand, flake without any inputs at all can still be used. Oh, wait, so one important thing to note is that a flake's consumer can override a flake's transitive input by setting follows. Flakes as flake inputs. Description, inputs, then input can be used and outputs as an X attribute set, which follows a schema. The flake schema, to be precise, case in point, a flake-like. Weird, but okay. Inputs, Nix package sets unstable, outputs packages, Nix default. Results in, okay, non-flake as flake inputs. Flakes can take arbitrary paths as inputs. This is mostly used to bring some package source into the flake and then pass to packages to produce an Nix package. For example, description inputs non-flake input, flake false, non-flake input. Wait. Wait, outputs is a function. Yes, outputs is a fucking function, bro. And what it need. Oh yeah, it's function because it's not necessary to be a function. Or is it? I think it is. Yeah, because it's gonna be freaking evaluated. What the hell? Okay, let packages, imports, Nix packages unstable. Non-flake input. Uh-huh. The directory that is passed as an input contains a single file. Outputs are arguably the most useful part of Flake. They allow Flake consumers to use Flake's contents. Defined broadly into categories: system-specific. Such outputs often rely on platform-specific components. System-independent. Outputs, the attribute in Flake Nix needs to be a function that produces an attribute set. Simplest example is just returning empty outputs. And individual outputs are attributes in this set. Flake without outputs doesn't have much purpose beyond an exercise in writing code. System-specific outputs. Packages. Dev shells. Apps, fairly well described in NixOS manual. They're effectively the primary target of Nix run. Do know that apps need to follow specific schema. What the hell? An app is specified by a Flake output attribute named apps. The only supported attributes are type, program, I mean, I guess it has something to do with like linking legacy packages. I don't need that. Checks. Oh, nice. Default behavior is to check the Flake against the default schema and emit warning. Checks are also derivations, and it's possible to define custom ones. To that end, they can still be used as integration tests. Checks, package test, mk derivation, package test, don't unpack, yada yada. Check phase, install phase. Jesus. That gets more and more complex, man. I'm a custom package. If I'm a native built input, self packages. Okay, so we are doing the default package, which is shell script. NixOS modules default. Environment system packages. Okay. Checks. So we're doing derivation, which takes native built input. Where the heck is foo, bro? Oh, wait, what? Hmm. Okay. Assert machine execute foo. Damn. Not bad, not bad. System independent outputs. Overlays. The main purpose of a Nix overlay is to push a new or override attributes of packages. As an example, a flag below adds a custom package called foo so that the consumer, in this case overlay test, check inside the same flag can just add the overlay when initializing packages and call packages foo without an overlay would produce attribute foo missing. Jesus Christ. Foo, okay. Overlays default, so final pref, what the hell? Okay, so currently it's partially applied function. Okay, so we are inheriting self packages pref system. Oh, okay. Don't understand. The purpose of an Nix overlay is to push a new or override attributes of packages. As an example, the flag below adds a custom package called foo so that the consumer can just add the overlay when initializing packages and call packages. Foo without the overlay would produce attribute foo missing. Nix packages overlays, self overlays default. File prep. So here we are doing inherit. Oh shoot. Okay. So yeah, we are, so it inherits foo from here, so it kind of puts it here. God damn it, dude. But yeah, I mean, so final is a function. Okay. Okay, so this thing produces a function that, god damn, dude. So final. I don't see no final in here. So I guess this final is just like, final prev. Prev is prev system. Okay. All right, I'll look that up. Exists to, so NixOS configuration exists to be consumed by NixOS rebuild, flake graph, hash hostname, other NixOS rebuild options. With this, we can manage the entire NixOS machine. The output is the first candidate to be set if migrating from the standard NixOS install with the system configuration under etc NixOS. Okay. NixOS configurations, my machine. Yeah, I have that. Templates are meant to be used. Okay. NixOS modules. Flakes can provide NixOS modules that can be units of a system configuration. Okay. Damn, Flakes rules. Flakes rule. Home manager modules, despite not being part of a standard Flake schema and having various names, home manager modules are quite commonly encountered per project Flakes. Lib and other non-standard outputs. Flake outputs are a proper Nix attribute set, so it is common to see some functions which built on top of the Nix syntax to be available as .lib output. Standard Flake schema does not recognize these outputs, so Nix Flake check emits a warning. I've personally not encountered checks for lib output, and I've done something like this. My awesome funk always returns false for any input. Nixconfig. This top-level attribute allows specifying nix.conf values for the flake. In my experience, it is most often used to specify extra substitutors so that Flake's consumers get precompiled packages from caches other than cache NixOS. This attribute is entirely optional. Huh. Nice. Frequently encountered code patterns. Self as an argument for outputs. Self is a reference to the flake itself. This is how the flake components, usually outputs, can reference other flake components. Outputs, self. My outputs built-in trace, self, what? Self is not really needed in the flake, it can be hidden behind. I don't think. This is how the flake components, usually outputs, can reference other flake configurations, other flake components. So outputs, self, my output, built-in trace, self, okay, Nix all my output, trace. Okay, makes sense. Add in flake graph. Flake utils, flake parts. Certain parts of the flake require its developer to write a bit of a boilerplate. We could take advantage of Nix dynamic nature by making packages a result of a function adopted from bash flake template, but copying around this boilerplate would be kind of boring. Let's reuse it from existing library. Outputs. Let supported systems for all systems. Nix packages for all systems. Uh, is it import? Yes, it's import. We don't have include. Attempt to call something. Mm. What? Oh, nice. Lib. Now we can take a look what would we have in standard library. Oh, that's a lot of functions. But what I wanted to take a look at, gen address. I don't understand that. Which is attempt to call something which is not a function but a list. Well, yeah, that's true. So like we are calling that, but we are ending up partially applying it because we need to do like some kind of oh, okay. Okay, and that's basically just a map. So system, import, Nix packages, inherit system. Okay, now we have Nix packages for, okay. Nice. But copying around this boilerplate would be kind of boring. Let's reuse it from the existing library. Flake utils. looks much more neat. One problem with such approach is that libraries like flake-utils define their own domain-specific language built on top of Nix. This language would need some extra time to get adjusted to. Whatever. An alternative to flake-utils, flake-parts, is more explicit about the type of its outputs. It also does a few other convenient things behind the scenes, like magically creating packages, allowing composing flakes like modules. Its DSL does take a bit of getting used to and requires knowing the basics first. So getting started. Existing flake, so we are adding flake parts, leap mk flake. Okay, so that's a framework. That's a framework. Top configs. Ports, flake, systems per system. That sounds not bad. That sounds not bad. Okay, I guess let's take a closer look at what we have. So we have flake parts in here. We are defining our outputs. On dev shells. MK flake. Imports flake systems per system. Recommended. Move all package definitions here. Per system. Function from system to flake-like attributes, omitting the system attribute. Modules defined here have access to the sub-options and some convenient module arguments. Per system packages. An attribute set of packages to be built by Nix build. Apps, programs runnable with Nix run. Meta, program type, bundlers. Damn. Okay, cool. We've covered the basics of NixOS. We have in. Oh shit! It like parts. I was looking at the wrong function. Okay, so built-ins, module arguments. Oh, yeah, that's that one actually I wanted to. We can see with is a variable names used specifically in flag parts. It stands for the output of this flag, but pre-filtered for the current system. In standard flag, self refers to the entire flag. If you want a package from it, you have to specify a system manually. Not language feature, just a part of a variable. Okay. All right. Well, then let's take a look at built-ins. Built-ins, MK Flake, make flake, make flake, make flake. What the hell? Why I don't see it? Flake parts, lib. Then slide make flag between your outputs. Okay. At the input, slide mk flag between your outputs function head and body. Outputs function head and body. Okay. So this is head. This is body. Okay. And that's like it. So let's go over our config once again. This what NixOS in this case, and what? How do I? What? Okay, let's go over outputs once again. System specific outputs. Packages, systems, so that's our flake. NixOS configuration, small machine, systems. So okay. Let's add a few things. Imports optional. Use external flake logic. Flake. Is it like per system dev shells default? God damn, dude. Sustain systems for which you want to build the per system attributes. Flake. Oh. So first it's imports. Then it's flake. Then it's systems. And then it's per system. Recommended. Okay. Okay, systems, flake. whatever, let it answer us. Okay, now that's already an explanation of everything. Nix develop. Okay, it built fine. Understanding mkflake. Mkflake is the core function of flake parts that performs the magic of multiplying your configuration across multiple systems. Takes two argument, module argument, inherit inputs part. This ensures inputs is available to all modules. Okay. Oh, it takes two argument. Inputs. Okay, that's actually damn convenient. The module, the configuration set, system imports, import flake systems, and per configuration. It initializes the NixOS module system, the same engine that powers, loads the default flake parts modules, which define options like per system, systems flake, etc. It evaluates your config against these options. It returns a standard flake output attribute containing packages, dev shells, NixOS configurations, etc. How do you know what fields to use? Her main top level ones. Systems required for list of strings. Okay. Imports, type of paths or modules. The module system merges everything referenced here into one big config. Flake modules, OBS Nix, okay. Per system, the magic one. Function defines configuration that applies to one specific system. Per system, config, packages. Calls this function for every system and systems. Collects the results and puts them into the standard flake output format. Dev shell per system. Packages self. Oh. Flake top level outputs attribute set defines attributes that don't depend on the system, like NixOS modules, overlays, or template. In. How many such functions can I have? Is function which will be called for all the systems. So basically with Okay. How many per system functions can you have? As many as you want. Every module you import can have its own per system definition. And when you have multiple per system blocks across different files, flake parts merges them. Module A, module B result they merge into one big per system function that returns both packages. Damn. If they conflict, Nix will throw an error unless you may use MK force or MK priority. Nice. Per system, you write as a template. Takes this template and runs it in a loop once for every string in stuff. Yes. Okay, now give me the breakdown of the format and organization of module. Best practices for module writing. Writing a configuration is different. Do not make assumptions about inputs. Do not traverse inputs. Why modules? Flakes are configuration into focused units, each in their own file. Allow users of your library flake to easily integrate your generated flake outputs into their flake. Okay. Do not traverse inputs. Use per system when integrating an existing library. It might be easy to add its options in the top level namespace only. However, as most build and test work is done in per system, users expect to be able to use it in that context. Bundled with existing flakes, most modules are about some piece of software that it integrates. Ideally, the flake module is bundled into the same flake. Man. The module system, okay, let's just see that. Minimum module format. Per system, packages, my app, top level, a function taking module arguments, module body, attribute set with per system config. Okay, the module system allows modules and submodules to be defined using plain attribute sets or functions that return attribute sets. When a module is a function, the module system and flake parts pass various attributes to it. These attributes are called modules attributes. Okay, config Values of current module scope containing the merged result. Okay, probably don't need that. Options. Lib. Okay, top level module arguments get system with system. Man. NixOS configurations. Enter the scope of a system. Nix configurations with system. NixOS system. Expose packages, inputs, and inputs as module arguments. Special args. Modules. This module could be moved into a separate file. Otherwise, we might as well have used context config packages directly. Okay. Every file is a module pattern. Each module is self-contained. They don't import each other. The module. Hello, hello. All good, all good. I'm a bit tired after streaming through the whole night. I think we have, yeah, it's 6.5 hours of a stream. But I finally learned the goddamn Nix language. I don't know what took me so long to do that. Like, it's literally been years. I think around like 5 years since I've been using the technology and didn't put enough effort to properly learn it. I was just scrambling thing about around until it worked. And ironically, it turned out to be not that hard. Like, the language itself it's very, very minimal. It literally is designed for you to pick it up in a day. Okay, so let's see. Module format and organization. Each module is self-contained. They don't import each other. Yes. Key arguments in per system, and per system is, yeah, per system is basically our main entity in the module, right? Yeah, module body attribute set with per system config and options. Okay. Oh, that's actually a good cheat sheet. how did I do? OBS. Now let's put that in dev shells. Okay, so out of main arguments in our module, we are gonna have packages as Nix packages for the current system. That's gonna be okay. That's gonna be an input. Let's say system self flake outputs. How you can reference the outputs, but okay. Inputs, system pre-selected, config, cool. Okay, use self, not self, system already pre-selected. Don't cross import modules. Why do we have inputs? Wait. Oh, okay. It's basically the same as just a regular self. Good. All right, now let's take a look at, let's start with OBS. First system packages self. OBS streaming. Need to take a look at this wrapper. Plugins are available from the OBS Studio plugins. They can be installed by either wrapping the package with wrap OBS or using Home Manager. Well, oh, we actually have a freaking damn it. We actually have whole Nix packages, so we can reference what we are interested in right here. Packages by name, wrap, no, that's oh shit. Okay, so it's packages. Top level applications video OBS Studio wrapper.nix. packages, top level, applications, video, OBS Studio, rubber.nix. Okay, let's take a look. Symlink join OBS. Symlink join. Okay, so it should be NixOS module. We have our inputs, we have plugins, which is an optional input. Well, yeah, wrapper is a function. So what the hell Symlink join does? Native build inputs, make wrapper. Post build. Some plugins need extra environment. Well, it joins Symlinks. Okay, I'm gonna be satisfied with knowing that. So now we will have a list of our plugins, self packages, OBS streaming. Oh, okay. So we have I kind of don't understand why we have two packages here. In our configuration, why we have not twice. Okay, let's see what that dude can answer us. Plugins. Is the primary package descriptive, clear about it? Is convenience alias? Self packages, OBS self, create alias. Okay. Okay. So yeah, we can skip the alias. is OBS streaming, wrap OBS. And how do we... Oh, damn, we had a link on the wrapper here all the time. Okay, what do we have here? Plugin arguments, wrap command line. That's a freaking function that does wrapping. Okay, we want to conditionally enable CUDA support. Oh, that's actually true. We do want to conditionally enable it. You need to override the base OBS package first, then wrap it. Per system. So okay, we're doing if enable NVIDIA. So okay, packages, OBS Studio override. Okay. There is no chance that without it could have been enabled by default. Yeah, we can actually test that shit. Whatever. Yeah, launch anyway. Let's see. Settings, stream, appearance, general, output. That's, no, that is a video encoder. Okay, we do need to we do need to add CUDA after all explicitly, so or make it a configuration option. So if this is a module, we are allowed and then we are composing our flake via flake parts into modules. Each And is it a good idea? Use module systems options. Okay. Aha. Module arguments with system get system options. Option declarations of the current modules code is primarily useful to inspecting options, metadata, or creating references. And I cannot access the entire set of module argument. Okay. Options. Okay. libmk option. Type libtype spool false enable. Okay. Now per system. Okay, Okay, packages, OBS streaming. Shoot, man. Okay, so packages. Let the hell? How it was said again? Okay, what was the example that I've sent? Oh, geez, I had it in here. Package, OBS Studio override, the support. Okay. Config, and then we should be able, so it's like config OBS enable NVIDIA Axon. In, okay. Has an unsupported attribute per system. This is caused by introducing a top-level config or options attribute. Add configure immediately on the top level instead, or move all of them into the explicit config attribute. Module arguments config explicitly named parameters will be in per system. See below. I don't understand. Per system config packages import. Okay, let's go for examples. Config all module args, obtaining all module args. I don't know. Dog food, or reusable flake module. Output. Oh, it was s config. Contains the merge result of all options definition from all modules. So we need options, right? Options. This is primary useful. Top level module arguments. Get system module with system. Dude. How module arguments work. Per system module args, packages example, obtaining on module arguments. Add configuration attributes immediately on the top level or move them, namely per system, into the explicit config attribute. Per system. Oh, so no, I don't fucking understand. Couple of problems. If you want to use NVIDIA Hub drivers, it cannot be top level on the same level as options and config. That's what error is about. Oh. So you are saying that basically I just need to like move this stuff to per system or something? A. Define it as an option with a list of package type and user specified values as default in the option. Define it as an option with list of package type and specify the values inside the config. Oh, that's actually nice. Like, yeah, why would you can just like set a configuration for two. Damn, dude. With list of packages type. Probably does not work as you expect. Cannot be a top level attribute on the same level as like Nix. On Day of Shields. So basically, like, I need to kind of export. Mm. That's hard, man. Per system. I want to read the per system thing. Per system inputs config merged configuration from a module. And give me a how to. Like, yeah, it will be freaking merged. Like, I'm pretty sure we are probably just need to do something like that. the hell? This is caused by introducing top-level config or options attribute that configurations attribute immediately on the top level instead, or move all of them into the explicit config attribute. Declare options. What can be configured? Use those options in config. You declare in options, then use via config. I mean, yeah, like let's just go this route, at least for the sake of, I don't know, exercises. Options, per system, packages, OBS streaming. Let's set the option in flake.nix. Okay. Packages, OBS streaming. I mean, well, let's try that. And now set the options here, right? Imports. Piece of shit. Flake modules, OBS, options. Wrong to what the hell? Damn, dude. Wow. Okay, so now our flake. Oh. When the module system sees options at the top level, it knows you're declaring configurations key. Okay. I think that's it for my voice. See you next week. And yeah, I'll be back on Thursday. Yes, we'll do a bit of video editing. And I need some sleep, man. Okay. See you around.